Find the equation of a circle which contains the points minus 6, 5, minus 3, minus 4, and 2, 1. 3 points fully specifies a circle. Only one circle can be drawn through 3 points. So we should be able to find the equation of this circle. The best way to do this is to use the expanded form of the equation of a circle. And we use the fact that each of these 3 points is on the circle. So each of these 3 points must satisfy the equation of the circle. So let's start with the point 2, 1. 2, 1 is on the circle, so it must satisfy this equation. So we plug 2 in for x and 1 in for y. Simplifying, we get 5 minus 4h minus 2k plus c equals 0. So we have one equation in 3 unknowns. And we repeat this process for the other 2 points. For the point minus 6, 5, we get the equation 61 plus 12h minus 10k plus c equals 0. For minus 3, minus 4, we get 25 plus 6h plus 8k plus c equals 0. So now we have 3 equations and 3 unknowns, h, k, and c. If we can find out what h, k, and c are, we can plug them back into the general form of the equation, and we will have the equation of this circle here. Basically, we're solving simultaneous equations, and the method and why it works was explained in the algebra playlist. We're solving simultaneous equations, so we take any 2 of them and try to eliminate one of the variables, h, k, or c. Now in this situation, the easiest variable to firstly eliminate is c. So we could take the first 2 equations and subtract them to eliminate c. So here are the first 2 equations. It doesn't matter which one you subtract from which. Either way, c's will cancel. When we subtract, we get 56 plus 16h minus 8k equals 0. We can divide all of this equation by 8 to get 7 plus 2h minus k equals 0. Now let's take the second and third equations. We subtract the third equation from the second equation. We get 36 plus 6h minus 18k equals 0. And we can simplify this down. We can divide it by 6, and I'll write it in above this one. If we divide this by 6, we get 6 plus h minus 3k equals 0. So now we're down to 2 equations and 2 unknowns. So we need to eliminate one of the variables. What I will do is eliminate h. I will multiply the top equation by minus 2. So we get a minus 2h here, which will cancel with the plus 2h in the second equation. So we have minus 12 minus 2h plus 6k equals 0 when we multiply all of this by minus 2. And we leave the second equation as it is. And we add these equations together. So we have minus 12 plus 7 is minus 5. We get 0 here. 6 minus 1k, 6k minus 1k is plus 5k equals 0. This looks like we'll get a very nice answer. K is 5 divided by 5 is 1. So k is the y value of the center of the circle. With k worked out, we can find h. So we can use either of these 2 equations. So I'll take the top one here and write it out. We have 6 plus h minus 3 times k, where k is 1, equals 0. Solve this for h. 6 minus 3 is 3. H plus 3 is 0, so h must equal minus 3. So now we have the center of the circle. H is minus 3, k is 1. The next thing that we want is c. So we can go back to the 3 original equations and 3 unknowns and plug h and k into one of them. Let's see now, the top one looks easier. So if I plug in for h, plug minus 3 in for h, and plug 1 in for k, and solve for c. So I'm just using the top equation. So what do we get here? 5 plus 12 is 17. 17 minus 2 is 15. So we 15 plus c equals 0, or c equals minus 15. So now we can write down the equation of this circle. So what I will do is I'll write the equation in here next to it. X squared plus y squared minus 2 times h times x. Well, h is minus 3, so we've minus 2 times minus 3 is plus 6 x. Minus 2 times k is minus 2 times 1 is minus 2. And then we have plus c, which is minus 15, and this equals 0. Suppose that we want to find the radius of this circle. Well, we can use the formula r equals root h squared plus k squared minus c. I'll just plot the center. So r is root minus 3 squared plus 1 squared minus c. C is minus 15, so minus c is going to be minus minus 15 or plus 15. So we get 9 plus 1 is 10 plus 25 plus 15 is 25, so the radius appears to be 5. And that's roughly what it looks like on this diagram. Distance from here to here is actually 5 units, same as from here to here. Find the equation of a circle which contains the points 0, 2, 1, 5 and has its centre on the line x plus 5y minus 15 equals 0. So here's the picture. Here are the points 0, 2 and 1, 5. The centre of the circle is actually located here. It's a point on this line. It turns out that there is only one circle whose centre is on this line and passes through these 2 points. So, just like before, we use the fact that we have 2 points on the circle. 0, 2 is a point on the circle, so it must satisfy the equation of the circle. So if we plug 0, 2 in and simplify, we get 4 minus 4k plus c equals 0. Since 1, 5 is on this equation, if we plug 1, 5 in, we get 26 minus 2h minus 10k plus c equals 0. Now, of course, we don't have enough information because any number of circles can pass through these 2 points. We don't have enough information with just these 2 points. We get 2 equations that have more than one solution actually. You see, this equation here has 3 unknowns, whereas this one only has 2. We can't solve between them for a unique circle. So we have to use the extra piece of information. HK is on this line. Now if the centre HK is on the line, then the centre HK must satisfy the equation of the line. So we plug h in for x, k in for y, we get h plus 5k minus 15 equals 0. So now we need to solve between these 3 equations. We have enough information. We will get h equals 5, k equals 2, c equals 4. So if we plug these values for h, k and c back up here, we'll get x squared plus y squared minus 10x minus 4y plus 4 equals 0. It's a straightforward matter to solve between these 3 equations. What you could do is subtract these 2 equations to eliminate the c's. Just take, say, this one and subtract this one, or vice versa. Take this and subtract this, and you will get an equation in h and k only. Then combine that equation in h and k with this equation here, and you can solve for h and k. Once you've found both h and k, plug the values back into either of these. Well, if you know what k is, you can just plug the single value of k back into this to get c, and you will get these values. So that's the equation of the circle. If you want to get the radius, you can use this formula here. Plug in for h, k and c. You'll find that the radius is 5. And you can see that on the diagram. The distance of the centre to the point 0, 2 is indeed 5 units. Find the equations of the circles which touch both axes and contain the point 6 minus 3. Now here is one of the circles that touches both of the axes and passes through the point 6 minus 3. Now a much larger circle, which I haven't shown here, will also pass through 6 minus 3 and touch both the y-axis and the x-axis. If a circle touches both axes, what do we notice about HK, the centre of the circle? Well, K is this distance here, and H is this distance here. As a matter of fact, we can see that h must equal the radius. H must equal r. The x value of this point is positive because the circle passes through the point 6 minus 3 and touches both of these axes. So the center has to be here. So h has to be positive. R is positive. The radius is always positive. However, k is negative. So it's only the magnitude of k that is equal to the radius. As a matter of fact, k is minus 3, but that tells us that the radius is the magnitude of minus 3, which is 3. But if we don't know that, we should still recognize that the magnitude of k is equal to the radius. So we just disregard the sign of k when we get the magnitude. The radius is always a positive number. Just to recap on this, since the circle must be located in this quadrant here, we can see that h, the x value of the center, must be positive. K, the y value of the center, must be negative because the point is below the x-axis. We can see that the radius, which is always a positive number, is equal to h, and we can also see that the radius is equal to minus k. K is a negative number, so if we minus it, we'll get a positive value. We can see that both h and minus k are equal to r, which means that h must equal minus k. Let's start by using the fact that h equals minus k. We write down the general equation of a circle, and we will replace h with minus k. So we'll have minus 2 times minus k, that's plus 2k. So we've eliminated one of the unknowns. Now we might as well use the fact that the coordinates of this point here are 0k. This point here has the same y coordinate as this point here. And it's a point on the y-axis, so its x value is 0. The coordinates of this point are h0. This point here has the same x value as the center, which is h, but it's a point on the x-axis, so its y value is 0. And of course, we can rewrite this point here. Since we know that h is minus k, we can write this as minus k0. So we can plug these 2 points into the general equation of a circle. So let's plug 0k into this simplified form of the general equation of a circle. So 0 goes in for x, k goes in for y. If we put 0 in for x, we get 0 squared plus k squared plus 2 times k times 0. This term will go out. Putting k in here will give us minus 2k times k, or minus 2k squared, plus c equals 0. We can simplify this down to minus k squared plus c equals 0. Now let's look at the other point, minus k0. Let's plug that into this equation. So we plug minus k in for x. Minus k squared is plus k. Minus k all squared is plus k squared. Plug 0 in for y. Minus k in for x here gives us plus 2k by minus k, which is minus 2k squared. We plug 0 in here, and we get just plus c equals 0. Actually, we get the same equation as this one here. Minus k squared plus c equals 0. The reason why is because once we know that r is both equal to h and minus k, and the circle touches the y-axis, then it must touch the x-axis. So this piece of information is really redundant. So we can actually ignore this. We just get the same result here. So now let's look at this equation here. Rearranging, we see that c equals k squared. What we can do is go back to this equation here and replace c with k squared. So now this is what we get. Finally, we can use the fact that 6 minus 3 is on the circle. So the only unknown that will appear in this equation after we plug in 6 minus 3 will be k. H is gone, c is gone. So simplifying all this, we get this quadratic equation in k. So let's solve this equation. If we factorize this equation, we get k plus 3 times k plus 15 equals 0. So that leads us to k equals minus 3 or k equals minus 15. Well, we can see from the picture that k equals minus 3. We know that h equals minus k, so if k is minus 3, it means that h equals plus 3. So the center of this circle here is 3, minus 3. We also have the radius. The radius is 3. Now we have a second circle with a k value of minus 15. I can't indicate that on the diagram, but it's a much larger circle passing through 6 minus 3, touching both axes and centered at the point with coordinates 15, minus 15. Anyway, we can go back to this equation here and just plug in each value of k in turn. If we plug in k equals minus 3, we get this equation here. This is the equation of the small circle. If we plug k equals minus 15 into this, we get the equation of the much larger circle.